Alright, so in the second worked example, the question says to calculate the mass of an object with a weight of 298 newtons on Earth. So we have to calculate mass and they give us the weight. So we write weight is equal to 298 newtons, and we are required to calculate the mass. Now we know that since it's on Earth, we'll be using the acceleration due to gravity of 9.81 meters per second squared. So we know that the relationship between weight and mass is given by this equation. Weight is equal to mass times gravity. So if we are to calculate the mass, we will have to transpose this equation for mass. So in transposing the equation for mass, we will get weight divided by gravitational acceleration. So we can substitute values here and look at the units. So the weight is 298 newtons, and we are going to divide that by the acceleration due to gravity, 9.81 meters per second squared. Alright, so we have to calculate mass, and we must show that the mass will be calculated in the unit of kilogram. So we'll first have to change this Newton. I'm going to continue the calculation here, and I'll say that since 1 Newton is equivalent to 1 kilogram meter per second squared, I could rewrite this equation here for mass as 298, and instead of Newton, put the kilogram meters per second squared, and I'll divide that by 9.81 meters per second squared. Alright, so we'll consider the units quickly here. In this case, we'll have meters per second squared divided by meters per second squared, so we could cancel this unit here, and we will be left with the kilogram. So all that's left to do now would be to work the values numerically. So numerically it works to 30.38 kilograms, and that's the answer.